Imagine a calculation so massive, so complex, that even if you hooked up every computer on Earth, it'd still take longer than the age of the universe to solve. Now imagine one chip, about the size of your thumbnail, solving it in minutes. That's exactly what Google's new quantum chip, codenamed Willow, just did. When Google announced Willow in late 2024, the headlines lost their minds. Parallel universes proven. Google confirms the multiverse. Even Google's own quantum lead, Hartmut Neven, said Willow's results lent credence to many worlds' quantum theory. But let's pause. That sounds cool, but is that really what happened? Spoiler, not quite. But what did happen might be even more revolutionary. The real story isn't alternate realities. It's something even more powerful, quantum error correction. Don't bounce yet. This isn't just tech jargon. It's the keystone that unlocks useful quantum computers. See, qubits are insanely fragile. Not just, oops, I dropped it fragile. More like, I thought about sneezing near it, and it fell apart. Even a tiny electromagnetic wave or thermal ripple can corrupt their state. Imagine trying to build a card house on a trampoline during an earthquake in a wind tunnel. That's what it's like to keep a qubit stable. Now, to fix that, you need error correction. But correcting quantum errors is like trying to catch a ghost with a butterfly net. Every time you measure it, it collapses. So how did Google solve it? They grouped 105 qubits together into something called a logical qubit. Basically, one virtual superqubit that can survive longer than any of its parts. And here's the twist. The more qubits they added, the more stable the system became. That's like building a sandcastle that gets stronger every time a wave hits it. Think of it like this. Classical computers have error correction too, but it's easy. Just check a few bits. Flip a 0 to a 1. Done. Quantum, every qubit is a diva. You can't copy it. You can't observe it without disturbing it. You need a team effort, like a choir balancing every pitch with constant harmony. And Willow? Willow made that choir sing. So why should you care? Because once quantum computers stop tripping over their own shoelaces, they'll start doing things classical computers can't even dream of. Let's get specific. Simulating molecules to find new cancer treatments in weeks instead of years. Designing next-gen batteries with atomic precision, no trial and error. Optimizing global supply chains, weather systems, even the stock market in real time. Cracking current cryptographic systems and replacing them with unbreakable ones. And here's the kicker. Quantum computers don't just go faster. They run a different kind of math. Classical computers test one solution at a time. Quantum ones test probabilities of many solutions at once. It's not speed, it's parallel possibility space. So when someone says, it would take a classical computer longer than the age of the universe, they're not exaggerating. It's like handing a maze to a mouse versus flying a drone over the whole thing instantly. Willow didn't just fly the drone. It stayed in the air without crashing. That's what changed. All right, let's circle back to that spicy quote about parallel universes. The idea comes from something called the many worlds interpretation of quantum mechanics. It says that when a quantum decision happens, like a qubit choosing 0 or 1, it doesn't just pick. It splits the universe and does both. It's dramatic. It's cool. It's not proven. So when Hartmut Neven said Willow supports this idea, he meant it metaphorically. Like, this experiment fits nicely if that interpretation were true. But scientists don't run experiments based on vibes. Willow's results followed standard quantum physics. No ghosts, no portals, no hidden dimensions. It's the difference between how we interpret weird quantum behavior and what the math and data actually say. So no, it's not opening a gateway to another universe. It's not channeling spirits. It's just showing us how deeply weird, beautiful, and accurate our current quantum theories really are. What Google actually did is even more incredible than a clickbait headline. They proved we can engineer stability in the weirdest, most delicate layer of reality, quantum space. And that unlocks a future we've only dreamed of, simulating black holes, modeling entire ecosystems down to quantum chemistry, even questioning the structure of space-time itself. No, not time travel, not spirit portals, just physics on hard mode. And we're finally beating the level. If this blew your mind even a little, stick around. We've got more real science, weird physics, and mind-bending breakthroughs coming weekly. Subscribe. Hit that bell. Because the future, it's already computing itself.